right. Hi, everyone. Thank you so much for attending the first session in Millennium STEM Alberta's Dissecting Diversity seminar series. We're so excited to have you here. My name is Paris, and myself and Mina will be facilitating the session tonight. Equality, diversity, and inclusion in STEM is a very important emerging topic of discussion and something that many individuals in various industries and research labs are taking note of. So today we are very grateful to be joined by Heidi Cossey, an engineer with many impressive accolades and accomplishments behind her. Before I introduce her fully, I'll just provide a quick rundown of how the event will go. So she has about a 30-minute presentation ready to go, and that'll go for half an hour. If you have any questions along the way, you can definitely pop them in the chat on the YouTube Live, and we'll be able to answer them at the end of the presentation in the order that we get them in. Just so you know, we are streaming to YouTube, so there's about a 15-second delay. So if you submit your question, just give us a little bit of a time to see it on our end, and then we'll be able to respond. I'll go into introducing Heidi. So she is an environmental engineer in training and a PhD student at the U of A studying geoenvironmental engineering. She completed her bachelor's degree in civil environmental engineering in 2015 and her master's degree in environmental engineering in 2018, both at the University of Alberta. Her current PhD project requires the integration of geotechnical and environmental engineering, microbiology, and geochemistry. She's won numerous awards throughout her career for academic excellence, research and teaching abilities, and leadership. And currently, she's the chair of the Engineering Young Alumni Council's Women and Diversity Subcouncil, vice president of the U of A's Canadian Geotechnical Society Student Chapter, and co-founder of the Faculty of Engineering's FEM program, which is a mentorship program to encourage women and other underrepresented groups to pursue engineering. So we've definitely got a very experienced speaker here with us today. So I'll turn it over to you, Heidi, if you want to share your screen, we can get that started.
Perfect. Thank you so much. And thank you for the introduction. Let me just, okay. All right, so you can see the PowerPoint here? Yes? Yeah, perfect. Okay, so hello, everyone. Thank you again for having me here. I'm really excited to be here this evening. So I'll just start off first with a land acknowledgement. So today or this afternoon, I am on Treaty 6 territory, which is the traditional lands of First Nations and Métis people. And where I work every day at the U of A is also on Treaty 6 territory. So I'd just like to acknowledge that. So thank you again, Millennium STEM, for having me today. I'm honored and excited to be here and to speak about my experiences and my perspectives as a woman in STEM. So I'll introduce myself. This will probably be a bit of an overlap, but my name is Heidi. I am a PhD student, and I'm studying geoenvironmental engineering at the U of A. So I'll explain what that is in a little bit here. So this photo of me right here is the lab that I'm currently working in. Well, not at this moment, but 3 to 5 days a week I'm in there. So it is a bioremediation lab at the University of Alberta. There's a bunch of flasks and pH meters and everything behind me. And it actually kind of looks like a chemistry lab more so than an engineering lab, but there's a huge overlap. So I am from a small town in Alberta. And then about 10 years ago, I moved to Edmonton to the U of A, moved to Edmonton to start at the U of A. And then 10 years later, I am still at the U of A, which is quite unusual to be there for that long. So like Paris said, I did my bachelor's in civil environmental engineering and my master's of science in environmental engineering. And then right now I'm working on my PhD. In my spare time, I'm involved in a number of organizations and groups. Some of them are the WISEST program committee, so that's the Women in Scholarship, Engineering, Science, and Technology. And I'm on the Engineering Young Alumni Council and the Women in Diversity Subcouncil, where I work to promote equity, diversity, and inclusion in STEM, or ADI. And I'm also the co-founder of the FEM program at the U of A, and I'll talk a little bit about that later on. So for starters, I'll talk a bit more about my journey, how I got to where I am now, and why I became an engineer. And I'll also talk about the importance of diversity in STEM and some of the work that I'm involved in trying to improve EDI in STEM. So, start at the very beginning, up in the top right, that's little Heidi in my sunglasses. It's a photo of a photo, so it's very blurry. But I grew up in Innisfail, Alberta. So if you don't know where that is, it's about 2 hours south of Edmonton, an hour north of Calgary, right off the QE2. So I grew up there. It's pretty rural. I think there's maybe about 7,000 people there. And so growing up, I was good at a lot of the subjects in school, math and science in particular. And I was good at English as well. And so a lot of my teachers told me that I should pursue English in university. And it's funny because I was actually much better at math and chemistry and calculus than I was at English. But no one had actually told me to pursue a career in STEM. So looking back, I find that kind of interesting. And so for me, I never considered engineering as a possible career choice when I was growing up. I didn't know any engineers, and I really had no idea what engineers did. I thought that mostly what they did was build bridges or design cars, and that wasn't quite interesting to me, and I didn't know enough, so I didn't think I would be an engineer. I also didn't have any role models in STEM who were women. And so not seeing myself represented in STEM or engineering just kind of didn't make me consider those as career options. So I didn't really think engineering was an option I would have. I kind of thought I would, well, actually I wanted to take a year off, but my mom wouldn't let me. She said I had to go to university, which I am very thankful for. But the main reason I wanted to take a year off is because I wasn't really passionate about any particular career option. And I really had no idea what I wanted to do. But since my mom said I had to go to university, I enrolled in a Bachelor of Arts program at the University of Alberta, and I moved to Edmonton. And so in that program, I took a bunch of interesting and a bunch of random courses. I took Italian for 8 months, but I can't actually speak Italian, so that didn't work out. But the courses that I really loved were my 2 calculus courses. And so I kind of thought to myself, you know, if I'm absolutely loving my calculus courses, maybe I should switch to a program that's more heavy in math and science. So for example, I was writing what I thought was my last calculus final in April, and I was quite excited to write it. I couldn't wait to be challenged with these different math problems, which is rare. Most engineers don't like calculus as much as I do, so if you don't like calculus, don't feel like that should deter you from being an engineer. But it just sort of made me think, you know, I should switch into a different program. And engineering intrigued me, even though I really didn't know much about it. But I thought, you know, let's give it a try and see. So I really went into it on a whim because, to be honest, I didn't research it like I should have. But I was really nervous about switching into engineering, but I still wanted to do it. I wanted to challenge myself, and I wanted to see if I could do it. So I was feeling particularly brave that summer. So I decided to switch into engineering. And so before doing that, I had to go back and take some courses at a career high in Innisfail because I'd never actually taken physics in high school because, like I said, I never considered engineering as a career choice. So I went back to the career high and I did physics 30 by correspondence and had to do it in 2 months because I had to write the diploma in June. So it was 2 months full of physics. So I remember the principal at the career high at the time. He thought it was ridiculous that I wanted to be an engineer. And he also said that I would fail physics 30 if I didn't take physics 20. And now you would kind of hope that an authority figure would be a little bit more supportive, but that wasn't the case. But, you know, I just thought to myself, this man doesn't know me at all, and he has no idea what I'm capable of. So I'm not sure why he feels so comfortable telling me what I can't do. But I ignored him, obviously, and so I did very well in physics 30, and so I got into engineering, which was really exciting. But when I started engineering in that September, I was still so intimidated by all of these other students. They really seemed so confident and capable. You know, the majority of them were men. And I remember many times the different guys in my class would offer to help me in courses because they assumed that I wasn't doing well or that I needed their help. And I actually remember one guy, we're taking a calculus course, and I was very good at calculus, and he was failing the course, but he offered to tutor me anyways, which I declined. I didn't need his help, but just kind of interesting dynamic. But so, you know, I didn't really feel like I belonged because I just didn't feel as confident. Everyone else seemed to be so confident, so sure that they belonged in engineering. And it wasn't till that after that first round of midterms, so a couple months in, when I realized that I was quite capable at engineering and I was actually quite good at it. So I realized that I belonged just as much as everybody else. And that was a really powerful realization for me. It gave me the confidence to continue on and to continue working hard and to speak up if I felt like I had the right answer or if somebody needed help. So that was really encouraging for me. But during the first year of engineering, it's very overwhelming because there are so many different types of engineering that you can take. And it's probably very similar in sciences. You know, there's so many different branches that you can go into, and it's so overwhelming because you don't have enough information about each of them, so it's hard to make that choice. And so in my first year of engineering, I really had no idea which one I wanted to choose. And like I said, I didn't know that much about engineering, so I didn't really know that much about the different types. There's about 40 different types, I think. Not that I could name them all, but there's a lot of different types of engineering. So one day in first year, we had a presentation by an environmental engineer, Dr. Anya Ulrich, and she was so engaging. And she talked about her career and all of the ways in which she was helping to save the environment. And after that presentation, I knew for sure that I wanted to be an environmental engineer. I was so excited about the program. So I went on to pursue environmental engineering. I learned about a bunch of different things. Waste management, which is actually so much more exciting than it sounds. Water treatment, cleaning up contaminants, air quality, hydrogeology, you know, chemistry. There's so much that we learned, so it was really exciting. And I also did the co-op program. And so I would highly recommend, if any of you are in programs that have co-op, if you could pursue that, I would do that. It's so great. I got to work for 3 different companies, 3 very different jobs. It really taught me what I liked and what I didn't like. And I learned so much, and it really helped me narrow down what field I wanted to work in when I graduated. Because even within environmental engineering, there's so many different branches. And so getting that job experience really helped me figure out which one I wanted to pursue. And so I graduated with my Bachelor of Science in Civil Environmental Engineering. And I actually graduated at the top of my class. So that was, you know, my proudest moment to date. And, you know, I went from being someone who was so nervous and felt like, you know, she didn't belong, wasn't sure if I could be an engineer, to graduating at the top of my class. So, you know, it really taught me a lesson that if you're, you know, unsure or you're scared of something, that doesn't mean that you can't do it. You can still try, you can still do your best. And just because you feel like you can't do something, it's not always indicative of your capabilities. So just remember that. So after I graduated, some graduation pictures here with some of my friends. So I went to work at AECOM in Edmonton as an environmental engineer. And so I was working in remediation. And that's when you clean up different contaminants that might be in the air, the water, the soil. The contaminants might be there from like a chemical spill, but it could also be from, you know, natural things like a forest fire. And I started working on a project called the Giant Mine Remediation Project, and that's in the Northwest Territories, right by Yellowknife. And it really fueled my passion for remediation and reclamation. So reclamation is where you return the land to its original land use after it's been used by industry. So for example, an abandoned mine, you might have to re-landscape it, plant some vegetation, redirect some surface water, and try to return it to its natural land use as best as possible. And so Giant Mine is an abandoned gold mine up by Alumni, like I said. And one of the byproducts of gold mining is arsenic trioxide dust. So it's a toxic dust, and there are lots of it up at this old mine. And so as a remediation engineer, my job was to work on a very large team and to try to clean up this arsenic dust in the best way that we could come up with. And so after working on that project, I decided I would go back to the U of A to pursue my master's in environmental engineering, focusing on remediation. I wanted to learn more about, remediation and hopefully help to improve some of the current industrial waste management methods. And so when I started my master's, I really had no idea that I would actually like research. But I took a chance on it, and I'm very glad I did because I loved it. So my master's project was, I think it was super cool. So it was looking at extracting residual oil that's been left behind in waste streams, and doing that with high pressure carbon dioxide. So the oil actually dissolves in the CO2, and then you can extract it, depressurize it, and it separates it from the waste. And so then the waste can be properly remediated and the oil can be reused. So it's a really cool project. And it really made me realize how much I love research. And so flash forward to a few years later, I'm still at the U of A. I'm in my second year of Geoenvironmental Engineering in the PhD program. And so the geo part of geoenvironmental is GEO. So it means geotechnical, so soil mechanics and the strengths of different materials. And then the environmental part is contaminant remediation. And so my research, like Paris said, involves environmental and geotechnical engineering. It also involves chemistry and microbiology. So it's pretty cool. It's a mix of, chemistry and biology and engineering, and the microbiology is a bit of a learning curve for me, but I'm getting there. So it's a really cool project where I'm working on the long-term behavior of mine wastes. And so for example, one thing that I'm looking at is the strength of these wastes. They contain a lot of water and a lot of clays. So in the long term, what is the soil behavior of the clay? And it can pose a really big challenge for remediation and reclamation if it's not developing strength over a number of years. And then another thing would be to look at chemistry of waste. So if there's contaminants in the waste, what kind of fluxes are we seeing? And what are the concentrations of those contaminants? Are they going to be dilute, or are they going to be problematic? So I mentioned before that Dr. Anya Ulrich was the woman who inspired me to pursue environmental engineering. And she's actually my PhD supervisor now, so it's come full circle. She's been a mentor and a champion of mine ever since the beginning of my engineering career. And I really can't tell you how powerful it is to have a mentor in your life, and I'm going to touch on that a little bit more later. And also as a side note, if you can't tell, I love grad school. It's amazing, and you should all do it after you finish your undergrads, PhD or master's program. They're all fantastic, so just keep that in mind. So I wanted to share with you some of the reasons I decided that engineering was the right career for me. So why you might want to become an engineer, or this might interest you, is if you want to increase somebody's quality of life. And for me, this also ties into the environment. So improving the environment and ensuring, if we are polluting, that we clean it up properly. But hopefully we're developing technology so that we're not polluting anymore. Another one might be if you wanted to be a creator of a new and innovative technology. And this is kind of a huge one right now. Everybody's doing this, which is super cool. And also, if you want to discover something new, that could be a huge benefit to society. And, as cheesy as this is going to sound, if you want to change the world, you should become an engineer. There are endless possibilities with what you can do with engineering and STEM degrees. There are so many ways that you can change the world, and it's really a matter of figuring out how you want to do that, because any of these careers are really just so amazing, and there's so many opportunities for you. And so I wanted to also share a few tips for anyone who might be an aspiring engineer, but this is also applicable to anyone who wants to pursue STEM or, explore different career options or avenues as well. So the first tip would be to learn about possible career paths. With STEM programs, you know, there are hundreds of paths that you could take. You can work in a lab, in a field, in an office. You can work in policy development for industry, research and development. You can work for various levels of government. So there are an overwhelming number of options. So do your best to try to figure out a few of those and what might interest you, because there's so many paths that you can take. Second tip, though, is to don't stress if you don't have it all figured out. You know, you might know exactly what you want to do. I have friends like that. They knew in high school what they wanted to do, and they're still working on that now, and it's going great. Or you might be more like me, and you had no idea what you wanted to do. But eventually you will find your way and you'll figure it out. So don't stress. You don't have to have it all figured out, you know, on day one of university or even after your bachelor's degree. You still might be unsure, and that's totally okay. My third tip would be to get involved and to take part in outreach activities. So some of the organizations that I take part in would be WISEST or APEGA, which is the Association of Professional Engineers and Geoscientists of Alberta. So if you are a student, you might want to take part in these as a mentee and learning about the different activities. Or if you are an undergraduate or grad student, you might want to take part as a mentor or a role model. I always find that giving back and taking part in outreach activities is really fulfilling. So it's something I enjoy quite a lot. My fourth tip, and perhaps the most important, would be to find a mentor or a role model, or better yet, a champion. So those three things are different. So a role model is someone who you look up to, but maybe you're not in direct contact with them all the time. A mentor is someone who's you're gonna regularly communicate with. They're gonna advise you and support you. And then a champion, which isn't listed here, is someone who advocates for you even if you're not in the room. So, for example, Dr. Ulrich is a huge champion of mine. She's always advocating for me when I'm not in the room, and that's led to many opportunities for me, and I'm very thankful for that. So do your best to find, you know, a mentor or role model at any stage in your career. They're going to be really valuable, and it's really nice to have that support and encouragement and advice from someone. And lastly, be brave. So, you know, hopefully you see yourself represented in the career path that you're interested in. But if you don't see yourself represented yet, please don't let that deter you. We all deserve a seat at the table. We have a very diverse society, and there are many different perspectives and experiences that are all valuable. So we all have something to offer. So go after whatever you're passionate about. Don't let anyone or anything stop you. If you don't see yourself represented, go after it anyways, and you will be forging a path for everyone after you. So just be brave if you can. And so I also want to talk about, you know, the importance of diversity in STEM in the workplace. And so I have here some of the benefits of a diverse workforce, and there are many of them. You can easily Google them. I'll just touch on a few very briefly. So some of them include, you know, improved productivity. You're going to have a much larger talent pool, improved company culture and employee retention, and it creates innovation. So STEM and engineering are really for everybody. Engineers and scientists are solving problems for our diverse society, and they're improving our quality of life. And so in order to be able to solve these problems effectively and to be innovative, we need a diverse workforce, and we need different perspectives. If everybody who's working on a team has the same perspective, the solution they come up with may not be the best for all of society, because it's just based on one perspective. And so I know there are a number of other speakers tomorrow and Wednesday who will touch on other aspects of diversity. So I'm just going to really focus on women in STEM here. So I'll give a couple examples of the importance of having women in STEM and gender diversity in engineering. So one example is years ago, when engineers were first testing different cars and looking at using car crash dummies, there were no women on that team, and so they had never thought to actually test a pregnant dummy to simulate the safety of a pregnant woman, which is quite important. But there were no women on that team, and so nobody had thought about that. And another example would be the grates. When you're walking on a sidewalk and you might see some grates instead of concrete. And so they, I don't know if you've ever worn high heels or pointy shoes across there, but it can be a little dangerous if your foot gets stuck in the grates. And so the solution to that was to come up with these solid footprints and put them over the grates, which is great. But the pace or the spacing between those footprints was actually the pace of an average man. So you would almost have to jump from one to the next. So equally dangerous if you're wearing high heels. So, if there had perhaps been a more diverse team in either of these scenarios, they might have come up with a different solution in the first place that might better represent the needs of society. So there are, a number of barriers and stereotypes that women face in engineering. There may be a lot of different jokes that might not be appropriate. Example of some of the stereotypes my peers and I would have experienced in some of the jokes we heard during undergrad were, the boys will do your homework, or you don't look like an engineer. And these might seem like small comments, but over time, they really start to add up. And so I recently watched a documentary called Picture a Scientist. And if you haven't seen it yet, I would highly recommend watching it. It's really good. And I'm just going to quote from one of the scientists in that film, Jane Willenbring. So she said, "A ton of feathers is still a ton." And so I think that's really important to remember. All these little comments over time, they still really add up and they still really start to affect you. So, keep that in mind. It's important for everyone to keep that in mind in our interactions with one another, and not just in STEM and engineering. So I will just show a couple of statistics of the current state of women in engineering specifically, and this was based on about 3 years ago. So if we look at the Canadian undergraduate engineering degrees awarded to women, in 2013 there was 18%, and then 2017 there was 19.7%. So it is an increase, but it's actually not that much. It's less than 2%, so not quite as substantial as we would hope. And then if you were to look at degrees or women enrolled versus degrees awarded, it's going to be a little bit higher percentage, but because people drop out of programs for various reasons, the degrees awarded is a lower percentage. So if you break up these degrees by discipline, you'll see a difference as well. So biomedical has almost 50% women. Environmental and chemical have around 40%. And if you were to look at mechanical or petroleum, you're going to see a lot less. And so these statistics kind of just lead me into my next point and sort of encourage me to do something. So, at various times in my life, I've been discouraged from pursuing STEM. And it's really made me realize the importance and the impact of having role models and mentors who are women in STEM, and also the importance of actively encouraging underrepresented groups to pursue STEM. And so, these numbers, I saw them a few years ago, and they haven't changed too much. And so that's really encouraged me to take action and try to do something. And so during grad school, about 3 years ago, I co-founded a mentorship program called FEM. So it's for young women in high school who are interested in pursuing engineering. And so I created the program within the Faculty of Engineering at the U of A. And every year we pair women from rural and urban communities in Canada. They're in high school, and we pair them with women who are in undergraduate or graduate engineering programs at the U of A. And the purpose of this program is really to create a network of young women pursuing engineering, and to encourage and support these young women to pursue STEM. And so far we've had over 200 young women in grades 10, 11, and 12 take part in the FEM program. So I'll show a couple of photos here. So this is from our first year of FEM. This is our first kickoff breakfast. This is from our second year of FEM. And we have a third year as well, but it was virtual, so we don't have a picture of all of us at the breakfast. But so far the program has been really encouraging. We've had to date 80% of the high school participants who have taken part in FEM are now enrolled in engineering programs at university, which is really exciting. And 100% of them are in STEM programs, so that's really exciting. The programs include like computer science, chemistry, physics, biology. And so this program is, just one example of a positive initiative that's been happening to encourage women to pursue STEM and to increase diversity in STEM. And this program also speaks to the role of mentorship and role models in encouraging underrepresented groups to pursue STEM. Having a mentor or a role model, I have found it to be so powerful, and it really makes a world of difference. So again, I encourage you all to find and connect with mentors and role models. They will help you find your place, and they're really going to help support you throughout your career. So I wanted to end my presentation on a really positive note. And on the weekend, I was putting the finishing touches on this presentation. And I wanted to include some photos of the inspiring and incredible women in my life who are in STEM. So I reached out to my network, friends and peers and mentors and colleagues. And well, actually, I got so many photos. I was planning on putting them all on one slide, but that doesn't do it justice. So I have several slides to show you of all of the amazing women that I know. And some of them are missing from these photos, but this is a good group. So the top left there, some colleagues that I used to work with at AECOM. It was the first all-female shift up at a site up north. Narissa is at a drill rig at the bottom there, and she just became a mother a month ago, so super exciting. And then on the right, we have Jennifer in one of her co-op terms. This one we have Maha, who's a PhD student in biomedical mechanical engineering. Eve is in the middle there. She just finished her PhD, and she's now working on a postdoc for Environment Canada, so really exciting. And then on the right, we have Nicole, and she's a geotechnical engineer. We have two Sarahs in this slide. So one of them is a water resources engineer. The other one just finished her PhD in environmental science. We have Maide. She is a postdoc who I worked with during my master's. And then again, we have Jennifer, who's in a gigantic pipe. Some more photos. Up at the top, we have Amy, who's working in a biological safety cabinet. Gabriella on the bottom, who's at a mine site. And then Wanya on the right, who is one of the powerhouse women behind FEM. She's helping me run the program this year, and she's fantastic. Then we have Alicia, who's all dressed in PPE. We have Heather, who's on my supervisory committee. She's wearing a fun pie-themed outfit. We have Marwa, who I've taken classes with recently, and she's wonderful. And then my good friend Steph from undergrad, who's an environmental engineer. We have Sush, who's a PhD student. She, I believe, is going to graduate very soon. We have Alam, and she's a postdoc that I work with. Salma Gigard, who was my master's supervisor, and May, who I work with on the Young Alumni Council. And then lastly, so on the left, we have Dr. Anya Ulrich, who is one of my most supportive mentors. In the middle, we have Jessica Vandenberg. She is so incredible and inspirational. She's the Associate Dean of Outreach at the Faculty of Engineering. And then on the right, one of my good friends, Victoria. She's a mining engineer, and she's also an international model. So she let me share one of her photos with you all. So, these are just some of the examples of the incredible women that I know in STEM. I'm so grateful for each and every one of them. They're also powerful and supportive. These women are engineers, they're scientists, they're my peers, they might have been my supervisors, they're my mentors and my study buddies at times. They really encourage me, and they push me to learn and grow. And so it's funny, I went from not knowing any women in STEM 10 years ago to now I know so many of them. I have a huge network. I honestly cannot keep track of them all, and that's an amazing feeling. So with that, thank you all for listening to me over the last 30 minutes or so, and I'm happy to chat and answer any questions that you might have. Thanks.
Okay, thank you so much, Heidi, for the wonderful presentation. You certainly brought up so many points that I would have liked to have heard maybe a couple of years ago. And one thing you brought up that particularly resonated with me was that engineers build our world, and we're like 50% female. So it's a no-brainer that we need more female engineers like yourself to make a world that caters to 50% of the population.
Absolutely.
Yeah. So I guess we'll get into the questions. The first one we have from the chat is, what made you choose engineering over a physics major?
over physics.
Mm-hmm.
I'll be honest with you, I actually don't like physics at all, which I know, engineers are supposed to like physics. I don't, but lots do. I much prefer math and chemistry. Certainly if I was better at physics, I might have chosen physics if I liked it more. But with either engineering or physics, I mean, there's so many options and so many ways that you can impact society. And I know one woman in physics that I know is working at the Canadian Space Agency. So there's just so many cool things you can do with either degree. Just for me personally, I'm not great at physics and I don't love it that much. So I went with engineering.
That's a good enough answer. So the second question we have is, would you recommend working in industry for a few years after undergrad before pursuing more education?
That's a really good question. Sorry, go ahead.
The second part of the question is, did your workplace experience change how you viewed higher education?
That's a good question. So I'll answer the first one. For me, I did work in between. I had actually planned probably to work for more than a year, but I just happened to want to go back to school right away because I really like school. I would say that depends on if you plan to do a PhD or not. So for me, I had no intentions of doing a PhD. I just thought PhD, like people with PhDs just became professors, but then I learned that, there's research engineers and there's so many other things you can do. So I hadn't planned on doing a PhD. I would say if you are planning on doing a PhD, you might want to work in industry just to give yourself a bit of a break from all that schooling. And working in industry might help you figure out exactly what you want to focus on. But that being said, if you know what you want to do and you don't need a break from school, then by all means jump right into it. If you're doing a master's, it might be a little different. You might want to do it right out of school, or you might want to work in between. I mean, you can't go wrong either way. And it might also depend on the economy too. So if it's going to be a tough year to find a job, you might want to pursue grad school. But if there's so many jobs, you can take your pick, then you might want to do that too. And the second question about whether or not working in industry changed my perspective of higher education. So I would say that it did, because when I was an undergrad, I thought I would want to do a master's just because I really like school. But I didn't see the value in a PhD because the only people with PhDs that I knew were professors. So, and as much as I admire them, I don't think I want to be a professor. So I didn't see the value in doing a PhD for myself. And then working in industry, I got to work with research engineers, and a lot of them had their PhDs, or in consulting, still a lot of them had their PhDs, and they were doing so many cool projects, and especially on the research and development side. And so that kind of opened my eyes to, if I want to do that as well, I probably want to get a PhD. So just getting that extra experience and seeing all that you can do with the PhD really helped me. And I got that from industry rather than undergrad.
Okay. So the next question you already kind of answered, so I'll skip over that one. How did you go about finding a supervisor for your master's and PhD? Do you have any tips for contacting the supervisor? I know you said you already knew Dr. Anya from your presentation, but I guess how would you give tips for other people?
Yeah, so for me, I actually had both of those professors in undergrad. And I still, though, you want to make sure that their research aligns with what you want to do. And most professors at any university will have a web page, and so you can go look up at their research, and you can also look up, current papers they might have published to figure out what they're working on. And then if you do find someone, and if you don't know them already, it's always good to send them an email, introduce yourself, perhaps include a resume or some highlights of the things that you've done that might be impressive, and just send that first email and then chat with them a bit. And then, if you both find that it's a good fit, then you can fill out that grad application. And I would recommend doing that fairly on. You don't want to wait too late, just because that might stress you out if you're kind of waiting and pushing deadlines. But definitely, I would start with checking out the research. And so when I was looking at doing my PhD, I looked at different universities other than just the U of A. Most people don't stick at one university. So I was checking other universities as well, but my research interest really lied with what was going on at the U of A, so that's why I stayed there. But I did check other institutes to see what research was happening there, so that's always a good place to start.
those are great tips. Another thing I would say is, especially for my experience as an undergrad, you have to email so many professors. Like you get rejected so many times as an undergrad. So that's another thing to keep in mind.
Don't keep those, don't take that personally, you know. I mean, professors are so busy and they have so many students asking to work with them, and sometimes they just don't need students on research projects. So, you know, it could always just be bad timing. So try not to take it personally if you have to send out, you know, 20 to 50 emails. It's nothing personal.
Okay, next question. Do you find that some people don't take you seriously because you're a woman? How do you deal with that?
Yeah, I have found that, which is frustrating. Actually, I would say I was taking some classes last year, and there was one person in particular who I found very difficult to work with. And he literally said to me, "You can't be taken seriously." So, you know, it's frustrating. And I'll be completely honest with you. I think he was very intimidated because I was kicking his butt in classes and labs, and he did not like that. And, you know, sometimes you can speak up if you have the energy, you know, certainly you can say something. But if you just don't want to deal with this person, you don't have to. You can honestly just ignore them if you want to. It's frustrating, certainly, and it will happen. And hopefully, you know, if you don't feel like speaking up, someone will speak up on your behalf. But I would say the majority of people aren't like that. And I mean, no matter where you're working, you're always going to run into someone who you probably don't want to work with. And that's just something you'll have to deal with. And, you know, sometimes it's worth the argument or explaining to them, hey, you know, this is really hurtful. Maybe we could approach it a different way, or maybe you shouldn't say that joke. You know, why did you think that was funny? And sometimes they will reflect and, you know, maybe think twice about doing it in the future. And sometimes they won't. So there's nothing that you can do to change their mind sometimes, and that's on them, that's not on you. So, you know, do your best, but if you don't have the energy to confront it, you don't always have to. It's not always up to you.
Yeah, I totally agree with that one. Next question. What time is it? Let me check real quick. Okay, we're still good on time. So do you have any advice for students trying to choose an engineering discipline, especially for high school students who don't exactly know what engineering entails?
Yeah, that's a great question. And, you know, I wish I did more research on this because I didn't know anything about engineering when I even started it. So I would say you can, like I said, I think there's about 40 different types. And so, you know, Googling it and trying to watch videos of different things that engineers do. If you happen to know any engineers, chatting with them and seeing what they do on a daily basis. I didn't know any engineers, so I really learned about it in first year because they do touch on all the different types of engineering. And at the U of A, anyways, you don't have to decide which path you go to. I'm not sure if it's like that in every university in Canada, but at the U of A, you get a year to take general engineering and then you decide. So you could also, one thing that's a good idea actually is to look on LinkedIn and just see what different engineers do. So you can look up a chemical engineer and look up their description. And if that sounds good to you, you might want to be a chemical engineer. Or you can look up someone who has a PhD or someone who might be an environmental engineer. And I would also recommend, so there are different, every province has a different engineering profession, I guess, different governing body. So we have a PEGA in Alberta, and they do outreach events quite often. And so going to those is also a good idea because they will feature different types of engineering. I've done a couple that were civil and some environmental. So it's always good. That can kind of give you an idea also of different types of engineering. But I would say the most powerful one would be LinkedIn, just because people love to give their job descriptions. They're so lengthy, so you can read many of them and figure out what you want to do.
Yeah, I really like that LinkedIn tip, especially with your discipline. It's so interdisciplinary. Like I would have thought of like microbiome, environmental aspects, and chemistry all in one. But yeah, it's really
yeah.
Next question. Do you think your opinion on women in STEM might change if you work full-time in the industry, as it can be more intense for women in a male-dominant industry?
Yeah, you know, I'm in environmental, and, you know, in university anyways, it's about 50-50. But then when I started doing some geotech engineering, it's a bit less. And I know working in industry, it really depends who you work with. and like I said, what discipline you work in. Petroleum would probably be a bit more challenging on a day-to-day basis than, environmental. But it really is a matter of working for a company that values EDI and finding the right people. I had a manager before who I didn't get along with, and he did not like me, but his managers were fantastic to me. And so I actually kind of had them as my managers instead of my direct manager, and that worked really well for me. But I would say a big tip, if you're concerned about that in industry, is finding the right company. If you find the right company and one that values EDI, hopefully it won't be a concern for you when you're working. And if it does come up, the HR team would be more than receptive to that if it's a company that values diversity.
Okay, I think maybe we'll go with 2 more questions.
Sure.
So another one we have from an external source is, what do you think are the greatest barriers to gender diversity in engineering?
Oh, this is a good one. There are a lot. I would say that for industry, it might just be attitudes. Sometimes depends who you're working with, perhaps depends what they grew up with and what they're used to. And that can really, depending, who you're working with, that can really be beneficial, and it can also be a barrier. Sometimes people might think that you can't do something. For example, one of my jobs, someone asked me if I could even drive a truck. Like, I'm from rural Alberta, and I can drive a truck, thank you. Just silly little attitudes. And so those can sometimes be barriers to you personally going further in a workplace. It can just be attitudes. It's also tough. For me, I didn't know what engineers did. So that would be a barrier, is almost that communication, where if you don't see yourself in a particular profession and you don't know what it is, then you're really not going to want to pursue it, because, if you think, oh, it's just all a bunch of boys working on cars, then why would you want to do that? So, there are a number of different stereotypes and, myths about engineering and biases that might hold you back if you're just a bit of misinformation, honestly, which can kind of deter people from even starting in engineering in the first place. And then there is a bit of a retention issue at times. If you're working and maybe you're finding that it's not what you had hoped it to be, and that can be, maybe because of the workplace that you're working in or the people you're working with. So there are a number of different, barriers, but it really might depend on what stage of your career you're in. But for recruiting, it might mostly be like misinformation and just not seeing yourself represented. So you're not really interested in that career.
Mm-hmm. Yeah, for sure. So I think we'll have one more question.
Yeah.
What things do you wish you had known? Sorry, let me repeat that. If you could travel back in time before you started your engineering journey, what would you say to yourself?
Okay, well, right out of high school, I would say, please pursue engineering. So I didn't, arts was a great year, but maybe I might have been a year ahead in my life if I hadn't done that. But, I would say have a bit more confidence and faith in yourself. I didn't know any engineers. I didn't know women in STEM, so I didn't see myself represented. And so that was a big barrier for me going in. And so I wish I had just been a little bit braver and maybe thought about engineering right from the get-go, rather than holding myself back a little bit. Eventually I got there, which is fantastic, but it did take an extra year just because I was really unsure. And so I wish I just had more confidence and when I was younger, and then I might have started right from engineering. So.
Wonderful answers. I think we're wrapping up now. I have some final words.
Well, thank you all so much for having me. I hope you enjoyed it, and I hope you all have a great evening. I know it's dark outside already, but hopefully you can still enjoy the evening. I know. Yeah, thank you again.
Thank you so much, Heidi. I hope you have a wonderful.
You all too. Thank you. Bye.
Thank you.